Now we will go on to Nolan and Aaron to present their project.
Sure. Well, hello. As we said before, I'm Aaron and my partner is Nolan. And we got involved with this project from the University of Delaware, where we're students at. And we became involved with a program called the VIP program, or the Virtually Integrated Program. And the Virtually Integrated Program was mentored by Sunita and Rudy, who helped us become involved in IU. Before we actually start, I would like to thank a couple people. More so, I would like to thank Wyona and Robert, but Wyona, I would like to thank for getting us up early to actually get work done every day throughout the week. So that was good, but yeah. So let's actually start.
All right, so the purpose of our project is described right here. It's to organize and display benchmark data that stress test hardware and software of HPC systems around the globe to allow businesses and institutions to compare them more holistically. Now that's a lot right there, so I'll explain each part. HPC, also known as high performance computing, systems are very important for businesses and institutions. They allow for research and data analysis to be done much more quickly than with a regular computer. So spec.org, also known as Standard Performance Evaluation Corporation, will contain a newly developed Spec 2020 benchmark suite. And since the data retrieved from this benchmark will not be able to easily be visualized on the spec.org website, you're creating a website to visually rank each system based on the score that it receives on the benchmark. So while current benchmarks like the top 500 supercomputing website are all linear based, the Spec 2020 benchmark contains a test code of kernels, which are based on real applications in engineering, science, and math. We're using the Spec Excel benchmark, which has been used for various amounts of years. As a demonstration, as the Spec 2020 benchmark has not yet been released. So visualizing this benchmark data is very important for businesses and institutions. It allows, as it illustrates which computers are currently outperforming the market. It also allows for the user to see which aspects of a computer impact its benchmark score, such as the CPU or accelerator it has. And it also allows for in-depth data analysis, which the spec.org website does not allow for.
So as Nolan said, our project is basically, to put it in simple terms, take data from spec.org and bring it onto a new and engaging website to rank supercomputers. So for how we actually do this, as you look on the screen, we start with a timer or a cron job that basically is a timer that will run periodically. And this timer will trigger a program or our web scraper to grab data from the spec website, as you see, and bring it to the database. So the web scraper will connect to the database, send data to the database, where then queries will be calling the data to our new engaging website. If you don't know what a web scraper is basically the process of taking data from a website or the internet and using it for some need. So for what we need it to do is the web scraper will take it and put it into the database. But part of the web scraper is there's a lot of different parts that take the data in mass, organize it into a more affordable and format benchmark that we can actually compare to each other. Once we take those benchmarks that we can compare, we will make sure there's no duplicates within our database, and then we will integrate anything new into the database. And this is what we basically use Jetstream for. It stores our database and our web scraper. All the code will be stored on Jetstream. So our database, we're using MySQL database or MySQL database. And the reason we used it was because of the vast knowledge within Jetstream RU who actually knew about the database. So if we needed, or well, when we needed any help with the database, they could help us. So how our database was formatted, we formatted it within one table. So one table of results. But within that table, there's one line for each system, HPC system. And so that line can be compared to rank the systems on a 1, 2, 3 format. But if you look at the graph on the right-hand side, this graph shows how many results we have as of right now, spec Excel results, but this only doesn't show how many results. It shows the different corporations, laboratories, and universities that submitted results. And this is basically what we actually need a new and engaging website for all these universities or laboratories to actually look and see which computer is best, because, I mean, who doesn't want to have the best computer? So this will compare so you can actually look to see who will be the best.
So on the right is a snippet of what the website currently looks like. We try to design the website around being clean and simple as to not hinder the end user's experience with features they don't need. This website was created on and is currently being hosted on the Jetstream virtual machine that we use. So by default, we decided on 6 different columns for the website, which are rank, base score, peak score, which is based on an optimized version of the code created by the sponsor and location, and CPU. And we believe that these were all essential parts of each HPC system, as they allow for them to easily be identified and compared. The website also features a change column button, which works as the name implies. This basically allows for the user to go on the website and change which default columns they see. So say they didn't want to see sponsor and instead they wanted to see graphics accelerator for each HPC, they could simply see that on the website. Each HPC system can also be clicked on to display all of its specifications, allowing for more in-depth views for each computer. And finally, search bar at the top allows for users to search by anything they want, such as sponsor or CPU speed, for example, so they can filter out which results they see. So for future directions, the current website that is very popular for HPC systems, Top 500, displays benchmarks from twice every year. So while the spec.org website releases benchmarks from every quarter of the year, you could display these on our website. So for example, if you wanted to see benchmarks from up to spring of 2020, you could just see that. Or if you wanted to see benchmarks from 2017, so if you wanted to look at old benchmarks, you could do that. You could also add other spec benchmarks, such as their CPU focused benchmark that they have, onto our website, just to see various other benchmarks. But currently we're using the spec 2020 unreleased benchmark as our end goal. And finally, we can add fancy graphs like the one that Aaron showed earlier, just to compare and visualize the data in a different way. So yeah, that's it. Any questions? Thanks for listening.
Yes, thank you.
Sorry, I think we can start with the same question that Haley got. What about the challenges and benefits of doing a virtual REU experience?
I can start. Challenges were definitely trying to actually work, but of course, waking up early and having the morning meetings helped a lot. So even though there was challenges, Wyona and everybody else definitely tried to make the best of it.
Yeah, I agree with that. I feel like collaboration wasn't as easy. Like if I could see people in person, it would have been a lot easier to just work on things together. Instead of Aaron and I decided to kind of split the project apart because we thought that would make it easier. But yeah, overall, I feel like because our project was focused on computers and website development, it wasn't that difficult to do online.
Okay. We have a question from Matt Vaughn, same as Haley. What could Jetstream do better?
For me, I focused on the web scraping side and actually integrated it into the database. Unless Jetstream can actually write code for me, which would take the fun out of actually this project, I think Jetstream helped a lot. It just was there. I can always access it. So I don't know of anything it could do better other than write code, but I don't want it to do that.
Yeah, I think it did everything I wanted pretty well. Like, there's just having a virtual machine was really nice, so I didn't mess up my own computer. And it was really good for us specifically because it could host the website 24/7. So that was really nice.
Good. We have one question from Jonathan. How many total results do you have in the website right now? How many
So
rows do you have? Yeah, how many rankings?
We have about 87. That's not an exact number, because every so often there will be new results added. But as of right now, we're using Spec Excel results, and those will always change.
Okay, great. Any more questions from the audience? Oh, okay. We have one from Jonathan. Also, this one's for Nolan. What did you do to prevent SQL injection on the website?
So currently, not much. I mean, we had I tried to secure the website a little bit, but I haven't done that much in terms of SQL injection because I thought that would be more of a later issue for when we're actually getting the server up and running. Because right now we just wanted a basic framework for what the website would look like. So didn't really add any SQL injection prevention.
So I wanted to point out that Sunita put on the chat two different things. So one was a piece of information about the vertically integrated projects that both Nolan and Aaron were participating in at UDEL. And also a link to the spec website. Thank you, Aaron and Nolan.